Hi, this is Kevin Trainer. Welcome to my tutorial for the Chapter 1 Zelle exercises. In this case, we're not going to do the exercises. We're going to do some kind of similar things to get you ready to do them. In my kind of teaching approach of see one, do one, teach one, the C one is what happens here in the tutorial video. The do one is the work that you do when you do the assignment. And the teach one is the thing that we begin when we have students show us what they did on their assignment when we get to the next class. So here's the tutorial part. Before we get in the first of the two exercises that we're going to do a program that kind of helps us kind of understand the plumbing of Python programs a little bit better than maybe we would get from reading the textbook. Okay, we're going to do it a little more experientially. So I'm going to go down to my dock and click on the PyCharm Edu. And this is really the first of these tutorials. I'm only going to do one version. I'm not going to do a version for the Mac and a version for Windows, just a single version. I'm going to use my Mac virtual machine. So things might be a little different on Windows, but probably not very much. Here on the Mac, the way I create a new project is I get this splash screen and I say create a new project. And it's going to go into my Python course, which is great. And I'm going to use a similar naming scheme that as the one that I taught you in the tutorial on how to do your work and submit your work. But I'm going to do this for a tutorial and not for a set of exercises. So how am I going to do it? Well, I'm going to put my last name, underscore my first name, underscore. Instead of exercises, I'm going to say tutorial. Okay. Or if I had, some other kind of project, I'd give it a name. And then this is for Zelle, underscore chapter, underscore 01. So when I go back to find that, I can find it. And again, I want the version of Python that came with the version of Anaconda that I just installed. And here this one is 3.6.0, but yours might be more current than that. Okay, and I went to create, gave it a click, and here's my project. Looks good. And the blinking is what goes on, at least here in my virtual machine, when it's kind of building the project infrastructure. It's copying things, it's recording the metadata, all those things, making sure all the packages are installed, all that kind of stuff. And depending upon how fast your machine is, this might take a little bit of time, or it might take a lot. Okay, well that's done. All right. So the first thing I'm going to do is I'm going to create a Python program called plumbing.py to help us understand this. So I'm going to right-click on the name of my project, so I want a new Python file. And I'm going to call it plumbing. And remember the names of these Python files, which we call modules, are typically in all lowercase with optional spaces to separate words. Okay, but this one's just called plumbing. I don't have to add the .py because that's what comes from this control down here. Click on OK. All right. So let's follow the conventions for putting a comment with the name of the file up and a comment with so the intention of the program. So I'm a little lazy, so I'm just going to type it in and then turn it into a comment with my toggle comment keys. So I'm going to say file colon plumbing.py. That's good. And I'm just going to use, on the Mac here, it's control / to turn it into a comment. On Windows, it would, I'm sorry, on the Mac it's command for these hotkeys. On Windows it's control. I just got finished with the Windows tutorial. And then we're going to have a single line comment where we say what the intention here is. And I'm going to call this an exploration of Python module architecture. Okay, just kind of how it all works. All right, and I'm going to toggle that into a comment, command /. I'm going to skip 2 blank lines. That will give me 1, now 2. Okay, and now I want to have the code. So it turns out that the simplest thing that you can do in a Python module or program or script, whatever you want to call it, is you can just have plain old Python commands sitting out in the open, not in any kind of a function or method. Okay, if it was an object-oriented class, we'd call it a method. If it's just out here in a file, we call it a function. In any case, we don't have them if we're using this in the simplest possible way. And the simplest thing that we can do is to print some text, okay, on the output console. So we're going to say print, okay, and then in there we're going to say line 1. I'm going to put it into double quotes. You can actually get away with either a double quotes or apostrophes. The textbook that we're using here seems to like the double quotes, and I think that that's it's a nice practice. So that's what we're going to use. And we're just going to call this, we're going to say line, and we're going to say 0, 1. Okay. All right, that looks good. And let's have a carriage return at the end, so we definitely know that we ended that line. Okay, so this is about as simple as you can get. Okay, we've got comments, and I don't really do anything, but we've got white space, we've got blank lines and comments. Those are all non-executable things, and we've just got one line of code, print line 1. Okay. Do we have to save it? No, we don't have to save it. Are you compulsive and you want to? Well, okay, hit either Command S or Control S, and you can force another save. But believe me, it's already saved. And how could we run it? Well, we're just going to go up here to the left in the gutter and click on the play button, and it's going to play line 1. Okay, that's good. All right. So what have we proved to ourselves? Well, the rule is that any lines that are sitting out in the open in the module, not contained into some kind of a method, or in this case a procedure, they're just going to execute starting with the first one and then moving on. Okay, so what if we had 8 of these? So I'm going to do Control C to copy, and I'm going to say, I'm going to copy this, Control V to get that down there, and then I'm going to copy them both and paste them, and that's going to double it. So that's got me up to 4 lines, and I'm going to copy all that and paste it. Okay. And that's got me 8 lines. And now I'm going to go in these things. Change it to line 02. I guess I didn't have to put O's. I thought it was going to go over 10, but I didn't. 3, 4, 5, 6, 7. Oh, 2 6s. We don't want that. And 8. Okay, so now we've got 8 lines of code. They all say they want to print something. They're a little different, so we can tell the difference. Okay, let's run that. And as you'd expect, well, we get 8 lines of code. 8 lines of output to go with our 8 lines of code. Okay, so it looks like it began with the first one and it ended with the last one. Okay, so you can kind of look at the rules and say, okay, well, the Python interpreter is going to go into this module that we have, plumbing.py, and it's going to start to execute at the first line of code that it finds. It's not hidden inside of a procedure or a method. And it's going to continue on all of those lines of codes it finds that are not inside of a procedure or a method, and until it gets to the last line that's not inside of a procedure or a method, and then it's going to stop. Okay, that's good. Well, could we confuse it by adding extra blank lines? Well, let's see. I don't think so. Put a couple of blank lines here. Couple of blank lines there, couple of blank lines there. Okay, is it going to know to skip the blank lines? I think it will. What do you think? Well, let's see. So it's already saved itself. Let's well, perhaps it hasn't saved itself. Let's do Command S to save it. Okay. And now this is where PyCharm starts to bother me. I want this to save and run, but it's not. I don't really have this thing up here. So here's what I'm going to do. I'm going to go up to the little tab here, and I'm going to right click on it, and I'm going to say Run Plumbing. I think I can do that anywhere in the editor. Yeah, Run Plumbing. All right. And look, line 1 all the way down there. That worked fine. Okay. So, yeah, we may have confused it. So we've lost our play button accidentally. Let's see. I don't know why we've lost our play button, to tell you the truth. I think that's probably a bug. Good thing we didn't pay a lot for this. But that's fine. That works fine. Okay, so it's going to start at the top. It's going to do those things in order. Okay, what would happen if I added some procedure in here? Well, what would that look like? Well, let's just do a procedure. Define, def. Okay, some procedure, some proc. Doesn't take any arguments. Okay. Ends in a colon. Okay. Then we come down to the next line, and let's print. Let's print something else. Well, let's call this some proc 1. Okay. Alrighty. Now, what I've said is the rule is that it's going to execute all the lines that are just out in the open, not hidden in some kind of a procedure or method. So I'm not going to expect to see some proc 1. I'm going to expect it to be hidden. I'm going to expect to get line 1, line 2, go right to line 3. Even though I've got some code here, code that's inside of a procedure is just kind of loading up and getting ready. It's not, we're not executing it yet. So when we declare, we define a procedure, we're not saying run it. We're saying know this. Okay? And when I tell you to run it, run it. Well, Simon didn't say to run it anywhere. Okay, let's see what that's like. Let's run this. Got our play button back. So we're expecting just to go from line 2 to line 3. Let's see. Yeah, went right from line 2 to line 3. That's fine. Well, that's pretty cool. Okay. That looks good to me. Now, what about something like this? What if we wanted to get that code from Sunproc? What if we wanted to go in between line 4 and line 5? Okay, well, in between line 4 and line 5, you just have to type the name of the method. Well, let's put a blank line here. Let's say Sunproc. And we have to put the parentheses there. They would hold the arguments if we had any, but this one doesn't take any. Okay, so we're going to do print line 1, print line 2, print line 3, print line 4. Execute the code in Sunproc. Oh, it's not. It's hidden until we say to run it. So this is what we call a procedure invocation. This is the procedure, this is invoking it. We use its name to invoke it, and it should run that one time. So we should get line 3, line 4, Sunproc 1, then line 5, line 6. So let's see if that works. Let's give it a run. There it is. Line 1, 2, 3, 4, Sunproc 1, 5, 6, 7, 8. So it's pretty simple. You can take your code and you can put it into procedures, and we'll talk about why we would want to do that in just a minute. Okay, and you could use it as it's just going to get ready. Again, when you define it, you're just kind of saying to Python, know about this code and be ready to execute it when I tell you to. Don't execute it until I tell you, okay? And then when you call the procedure, invoke the procedure, then you get it. Well, could you invoke it several times? Yeah, let's do it 3 times. So let's copy this twice. So now I'm going to expect to get line 3, line 4, 3 copies of Sunproc 1, and then go to line 5 and 6. So, all right, let's give that a run. There's line 1, 2, 3, and 4. 3 copies of Sunproc 1, and then line 5, 6, 7, and 8. Well, that's nice. Okay. Now, let's go back to one call to Sunproc. I got rid of 2 of them. Got rid of some of the block lines. Now let's run that again. Again, I've lost my play button here, and exactly why I can't explain to you. But I'm going to right-click in the editor and say Run Plumbing, and it runs. And I'm getting 1 copy of Sunproc. That's good. Now, if I define the procedure Sunproc up on line 8, and then I call it on line 15, that works great. Okay? Something you have to know is in Python, I can't call it before I define it. So I can't say, okay, let's just call Sunproc right in the beginning. Let's see how that works. Well, we get an error. Unresolved reference to Sunproc. Well, why is that? Well, it's the nature of Python as an interpreted language that every time that we refer to some thing, some program-related thing, it has to be defined already. So we can't reference forward. We can only reference backward. Now this isn't true of all programming languages. In particular, one that I've used a lot, the Java programming language, is a compiled programming language, which means that the whole program gets processed before anything executes. And because of that, you can refer forward to things like procedures, and you can refer back, and everything works fine. But it's more typical for an interpreted language like Python to have the requirement that if you're going to refer to something, it already has to have been encountered in the linear flow through the file. So how do we make this work? Well, we just take our sumproc, which is all lit up with the red error signal, and we're going to cut that, and we're going to paste it down right after sumproc. This is as soon as you could possibly use it. Okay, now it's fine. So now it's going to come between line 2 and 3 because that's what we told it to do. So let's play it. And it's coming between lines 2 and 3. All right. Okay, so that's some of the plumbing things. So let's review what we know so far. Well, we know that any line of code that is not hidden inside of a procedure is going to be executed when we do a run. Okay. We also know that if we hide code in a procedure and we don't have another line of code outside of the procedure that calls it, well, we've kind of buried the map with the treasure. That's what happens when we define it, but we don't call it. We see that we can call it as many times from the outside code as we want. That's fine, but we can't call it before we define it. All right, that looks good. Now, let's look at something that we're going to do in the homework, and we do it in chapter 1, and maybe it looks kind of weird. Okay, and that is, why do we have a convention that we take our code and we put it into a procedure called main? All right, so let's take our original code that we have. Okay, we have here. And so we've got 8 lines of code. That's not a lot of code for a program. A program is usually a page or 2 or 3 long. So we might have 30 lines of code, 100 lines of code, 300 lines of code, maybe 1,000 lines of code. Okay. Well, that gets awfully long, doesn't it? So the typical thing that we do is that we organize our code in a way that makes it easy to read. Well, how do we do that? Well, the way to organize code is to take lines of code and place them into functions. Okay? So the simplest thing you can do is you can take all of the lines of code that you have that you want to execute, and you can place them in a single function, which is your main function. And now this is what we're seeing in the book at this point. Okay, so how could we do that? Well, a couple of ways to do that. One, we could say we want to let's have 2 blank lines here. We could define def main, that's the name of the procedure. We need parentheses to hold any arguments or parameters. We're not going to have any right yet. Okay, and we need a colon to get that started. Okay. All right, so we have the beginning of a shell of that procedure or proc, but our code isn't in it yet. Let's put our code in it. So let's highlight all the code. Let's right-click and say cut, and then let's put it right underneath that def for main and say paste. We're going to paste it here, and it's not indented. That's not going to work. So let's highlight that block of code again, and let's press the tab key. Now it's indented. Alrighty. So now we have all of our code in a procedure or proc called main. Okay. What happens if we run this file now? Does anything print out at all? Well, remember that we said any code that we put into a proc is going to just be hidden there. We're just essentially telling the interpreter, know about this code in main, but don't actually run it till we tell you to. So if we never tell you to run it, nothing's going to happen. So let's see. I'm going to expect no output. Let's run no output. Well, that's not really useful. So how could we get the code in main to run? Well, just what we learned before. We type the name of the method, main, and we put the two parens after it. They would hold arguments for the method, but we don't have any. Okay, so this is pretty simple. Okay, and I always want to make sure that we end that line. Okay, that looks good. So we want the interpreter to know about main, and then we want it to run it. All right, let's give that a run. Now again, I don't have my play button, so let's right click and say run plumbing. There we go. Now it runs it. Okay, well, this looks pretty cool. This looks pretty cool indeed. All right. Now, you might say, well, this kind of makes sense, but why do we put the code that actually starts everything, why do we put it at the end? And in fact, in many programming languages, when we organize our program, we put the main code, we put the code that gets it started. It's the very first thing that you see. Okay? Well, why do we put this at the end? Well, because we can't refer forward to main. So for instance, this works fine. Okay, that's working great. But if we want to, if we wanted to say, okay, let's cut this and put it at the beginning, because I think it makes more logical sense up at the beginning. It's kind of like you're in the beginning of a book and we're saying, well, okay, here's the table of contents. Here's what's in the book. Where's my paste? Okay, can't do it. Because this is an interpreted language, you can't refer forward. Okay, so we're stuck. I'm going to do a couple of undos. Command Z, Command Z, Command Z, Command Z. We're stuck with this structure that you see in the book. Okay, and that's how we get there. Now, does it have to be called main? It doesn't, but that is the typical, it's a naming convention. Okay, it doesn't have to, but if you don't do it, you're not really being like a real Python programmer. Okay, so could we change the name to something else? Sure. I'm going to show you, in fact, a feature that we have called refactoring. It's a way to change code in kind of easy ways and hopefully not change the functionality of it. But what we can do is we can double click on the word main to highlight it. Okay, then right click and then pick refactor and then rename. Okay, and let's call this instead of main, let's call it Waldo, and then come down and say that we want to refactor. Okay, down here, do refactor. Let's do that. Okay. All right. So we had only not to say refactor. It showed us what it would look like, and we had to confirm that we wanted that. Okay, so would this work if it had any procedure name? Yeah, it would. Let's run this. Runs like a charm. Okay, so main is just a convention of the name of the mainline code, the highest level code that we have. Okay, and so we typically are only going to, if we follow good practices, we're typically only going to have one line that is outside of a procedure. Okay, and what does that do? It tells you to run our main procedure. Okay, and couldn't we call it Waldo? Yeah, we can, but we're going to look like we're right off the farm. Okay, so let's go back and highlight this and right click and say we want to refactor, rename, and let's turn that back to main and refactor it, and then we have to go down here and say do refactor, and we refactor it. So now it's back to the way it's supposed to be. So every program that we're going to write that's executable like this, okay, this is a typical program that we're going to write in the beginning of the course at least, it's going to have this kind of structure, right? This is what it's going to look like. Now, why is this called main? Okay, I just want to go ahead. Well, because instead of 8 lines of code in our program, let's think we have 800, okay, or 80, all right. Then how would we organize our program? Well, we probably would want something to look like this. This is how, let's refactor this code a bit, okay? So let's say, let's have a procedure. Let's call it, we're going to define it, let's call it do first part. Do first part. Okay, so let's do this. So it's going to call it do first part. Okay, and so let's just take the first 2 lines and cut them up there, and let's paste them down here. Okay, well, that's kind of good. All right, now will this do the same thing? Well, not quite, because we've hidden the print for line 1 and line 2 in do first part, but we've never called it from anywhere. You know, we hid everything in main before, and we never called it from anywhere. Okay, and then when we added main, then we got all that code. So not only do we, when we refactor this to put things into separate modules, not only do we want to refactor it, do we want to put the code into a module, but we want to call the module. So let's try to run it before we do that. So I'm thinking we won't see line 1 and line 2. Let's see. Now we begin with line 3. But if we go back here, okay, if we go back here and we say we want to call do first part paren, we want to do that. Now that's going to run the 2 lines in here one time right before we do the line 3. So let's see that. Okay, so let's go up and run that again. And there you go. That's the whole thing. Now it turns out that there's actually a way to refactor code, and it's called extracting a procedure or a method. Methods are the names that we give to procedures in object-oriented programs. This is a non-object-oriented program for the most part. So how could we do this faster? Like, what if I wanted to take 3, 4, and 5 and put them in their own module, and 6, 7, and 8 and put them in their own? Well, here's the trick you're going to love. So you can highlight these 3 lines, 3, 4, and 5. You can right click and you say refactor and extract. So this is called extracting a method. Now, technically this should be called extracting a procedure, but we go down and say method. Okay. And it says, okay, I know what to do with everything, I just don't know what to call it. So let's call it something akin to we had. Okay, second part. So let's call it do second part. And say, okay. Okay, so what did it do? Well, it moved that code to a new method that it set up for us. It put the shell together for it, do second part. The code's there. It also put an invocation to that, a call to it, exactly the right part. Okay, so one of the things about refactoring code like this is you typically, the next time you test it, you typically expect it to behave the same way. So we're changing the arrangement of parts, but we want to change them in a way that we're not changing their behavior. It's just the way, one of the things that we're doing when we refactor is we're organizing the code to make it more readable, more maintainable. So let's run this version, and we should expect to see lines 1 through 8 in the right order. Yep, lines 1 through 8 in the right order. So let's take these last 3 lines and refactor these into their own module. So highlight them, right click, refactor, extract, method instead of module. That's a little confusing, but it'll be okay later. Okay, and then what do we want to call this? Well, we want another parallel name like do third part. Now hopefully if you're doing your program, you've got more descriptive names and more functional groupings than first part, second part, third part. But then you say okay. And now what have we got? Well, this is interesting. We've got a main that describes in a very nice high-level story what goes on in the program. Okay, first we call do first part, then we call do second part, then we call do third part. How do we know what goes on in them? Well, you find the methods and you look at what they do. Okay, is there any code that's not inside of a method that is going to be executed when we execute the module? Yeah, there is. There's one line. It's a call to main, the top level code. Now we can see why it's called a main. Okay, because we're intending to create other methods as we structure the program, and they're not going to be called main. Okay, now the name main kind of makes sense. It's the main thing. It's the top level code for our program. Okay, and how many lines are we going to have that are out in the clear, not in a method? Just one. So when we're writing this kind of program, these procedural executable programs, we're expecting to have just one line out by itself, or we'll find we'll have a little cluster of code where maybe we'll check a couple of conditions before we do that. But for the most part, if we're doing it simply like we're doing now, we've just got one line of code, and what does it do? It calls the main. Where do we put it? Well, we have to put it after the procedure main somewhere. Okay, could you put it immediately after? Yeah, you could. What's the convention that people do? They put it at the bottom. Okay, well, geez, doesn't that make it hard to find? Well, you know what? We know what it's going to say. We know if this is an executable procedural program, we know at the very bottom of it, it's just going to say main. Okay, so and we can go down and check, we can open this up and we can go down and check to the bottom. Oh yeah, there's our call to main right there. But we pretty much expect it to be there, and we don't expect a lot of razzle-dazzle down there. We'll learn to do a couple of fancier things surrounding that, but for right now, we just have the call to main. Okay, and again, having done this, if we run this again, we should get 1 through 8. So again, we've done this thing called refactoring. We've taken our code, we have edited it with the help of this refactoring tool that's part of the IDE. And what we do at every step is that we intend to have the result be code that functions the same way, but is easier to read and easier to maintain and easier to test. Okay, and once you see all that stuff together, then you look at a program that has just a short main and a call to main, and you go, oh, now I know why we have those as our conventions. Because in a real program that had a lot more work in it, we wouldn't only have procedure main. That, in fact, would serve as the main procedure. Okay, that's all the plumbing we're going to worry about there. Now let's take a look at the other 2 things that we're going to do for the assignment. So let's close this one. And let me just take a peek. I've got one already cooked here. So the first thing that we're going to do that's kind of like the so long, we're just going to do welcome. I'm going to call it welcome here this in my tutorial instead of hello world or goodbye cruel world. We're going to say welcome. Okay, so we're going to call it welcome.py. Okay, that's easy. So let's say we want a new Python file, call it welcome. Okay, and we don't have to put the .py on it. We'll just say okay. All right, and let's type a comment that says file welcome.py, and let's toggle that into a comment. And let's say a simple program that prints 1 line. That's what all these do. And I'm going to command right/that to toggle it into a message. Okay. Now I'm going to take an approach here. I want 2 blank lines between the comments and the code. The first thing I'm going to do it the simple way. I'm going to do it with a line of code that prints out welcome to my world, and it's going to be out in the clear. It's not going to be in a procedure. It's not going to be in a main. Okay, so let's do that. Let's say print parens for the arguments, double quotes, welcome to my world, and I'm just going to put a period there. I'm not too excited. All right, and I'll end that line. So yeah, we know that any line that's out in the code and not inside of a procedure should run when I execute the program. So let's go up and run this. And what do we get? We get welcome to my world. Well, I'm almost there. The only thing I haven't done is I haven't followed the conventions of putting my code into a main and calling the main. Well, what's an easy way to do that? Well, here's how I would do it. I would highlight the code I want to put into a main, and I refactor it there. So I'm going to right-click, refactor. I'm going to extract a method that's an object-oriented name for a procedure. And what's it going to be called? It's going to be called main, M-A-I-N. Okay? And I'm going to say OK. And I have refactored this into the standard conforming version of the welcome program that we want. That we want to show that we understand what a main procedure does, and we want to understand how to get our code into it, and that's it. We still only got a single line out here in the clear, not in a procedure, but that of course is your standard call to main. All right, so if we run this again after the refactoring, we should not have changed the functionality. We should just change it to a more standard, maintainable, readable version. So let's run it. Welcome to my world. So that one's all done. Okay, good. All right. So the version that you're going to do is it has a different message, but it's pretty much the same deal. Okay. Now, what's the next one I'm going to do? Well, the next one we're going to do is going to be called Math 101. And Math 101 comes from one of the examples from the book named chaos.py. Okay. So let's look at this. Okay, so how can we get an example from the book? Well, here's what I'm going to do. I'm going to go and find my way to the files that I had in the weekly schedule last week. Okay, so somewhere I've given you a link to the files that are in the book. All right, so I'm just going to open up the browser. There it is. For some reason it wants to go to JetBrains. I guess we were there last when we did the install. And I'm just going to go to my little home page because I know where to find it. And I'm going to go to my course info site. And right now, the course I'm working on, the summer of 2017 at Illinois. And here's the course. And just in the first class, we had a link for the code examples from Zelle 2nd edition, which is the book that we're using. So how can I get these to download? Well, I can right-click over that link and say download linked file. And if I look at the animation, that comes down to downloads. That looks good. And now what I'm going to do is I want to unzip that in the right spot. So I'm going to go to the Finder. And I'm going to open up in Documents. I'm going to open up, it's going to go to create a new folder. And I'm going to call it Zelle 2E example code. Oh, you know what? It comes up with its own name. I'm sorry. So I don't want to create a folder. Let's get rid of that folder. Goodbye. Move that to trash. Now, what I'm going to do is I'm going to come to Downloads here. And there it is. That's what I downloaded. So I'm just going to pull that up in here. And of course, it's a zip file. And the way we expand them in macOS is we double-click them. And I guess it's called code right now. And if I go to chapter 1, well, chaos.py is in there. So if I say I want you to start with one of the programs from the book and you don't want to type the whole thing, well, golly, here's where you can get the code. All right. All right, so what could we do from this? Well, I'll tell you what we could do. Let's leave this Finder window open, and let's open, let's go back to PyCharm Edu. Okay, and it turns out that you can just take a file from out of the operating system interface, and you can come in here and you can right-click and paste it. Okay, so that's what I'm going to do. I'm going to go find my Finder again. And I'm going to find chaos.py. I'm going to copy it. Okay, and I'm just going to go back to the user interface for PyCharm, and I'm going to right click on the project and say I want to paste it. And it's going to say, well, what do I want to call it? Well, I don't want to call it chaos.py. I'm trying to create a new program. And I look at my instructions and go, oh, what's supposed to be called Math 101? So Math 101, that looks good. Say OK. Alrighty. So share anonymous statistics. Oh, what the hell? I'm a generous guy. I'll say yes to that. So if you remember, this is a program that has some real fancy stuff in it. It begins, first of all, it has all the code in a main. Okay, it's factored in there. And it just has one line in the clear, a call to main. This is a pretty standard setup now. Okay, and what does it do? Well, it uses a print to put a prompt message on the console. The program illustrates a chaotic function. It uses an eval input, which we're not going to really learn in this chapter, but what happens here is that the input prompts, it writes out this enter a number between 0 and 1 colon. It writes that out on the console, and it waits for input, and then we're going to take the number that we get back, and eval turns it from a character string into a number, and this assignment statement puts it into the variable x. And then we have a loop. And what does the loop do? Well, the loop goes around 10 times. How does that happen? Well, that's controlled by for I in range 10. That's going to happen 10 times. And then we do some calculation. Okay. And we keep changing x, and we print it. So let's give this a try. Let's give it a run. And it wants a number between 0 and 1. So I'm going to give it 0.5. That looks good. And I'm going to press enter. And then it's going to run around the loop and give us these 5 chaotic values. Okay. Now, how could we change this around to become our Math 101.py? Oh, actually, I wanted to call this something different. I wanted to call this Math 105 because it's not the same as yours. Okay, so how can I fix this? Well, I am going to just go over here to Math 101.py over here on the navigation panel. I'm going to right click, and I'm going to say I want to refactor, rename it Math 105.py. Let's call it Math 505.py. So we're not going to confuse them at all. Math 505.py. Okay, refactor. Okay, so look, over here in the navigation panel, it's called that, and then up here in the editor tab, it changed it in place. Okay, so we're calling it Math 505. We'll see why in a minute. Okay, so we're going to want to change the comment up here. It's not nice enough to change a comment for us. So it's called Math, Math 505. Get that right. Okay. And what is this? It's not so simple anymore. So we're going to say, a lot of times I don't want to say a simple program 2. I just want to say, here's what I want to do. Print a series of integers starting a series of 10 integers. So we know how many we want. We want 10 integers. Starting with 5 and increasing by 5 each step. Okay? Now, is that ambiguous? No. 5, 10, 15, 20. So if you go to the end, you start with 5, you end with 50. Okay, how does that work? Well, let's look at the code that we have here. do we need to print this thing? This program illustrates a chaotic function. That doesn't impress me, so we're going to get rid of that. Okay, so the first line of output gone. Okay, so we just go right in there and we hit the delete key, which I have on my Windows oriented keyboard on my Mac. Now, are we going to need any input for this program? Well, no, this is a pretty static version of the problem. This is not the program that we're doing is not so sophisticated as the one that we're changing into it, because it's not going to take any input. It's always going to start with 5. It's going to step up by 5s. It's going to print 10 altogether. It's going to end with 50. Okay, all right. So do we need to get any input? No, we don't. So this, what's currently line 5, that's going to go away. So we got rid of that. Okay. Now, are we going to want to have some kind of a variable x that changes in some kind of slinky, chaotic way going along? Well, no, we're not, and I'll tell you why. Well, because each of these loops, this kind of a for loop, is a definite loop, which means it executes a definite number of times. Okay, it has a control variable itself called I, and we're not currently making much use of it. It's just used to control the number of times we go through the code in the body of the loop. Okay, so what could we do? Well, let's do this. Let's not manipulate x, so we don't need to give x a new value. Let's get rid of that. This is getting simpler and simpler. Okay, and then we just want to print the value. Now, if you can look, when we refer to x, well, it's not resolved anymore because we never populated, we never calculated. Do I want to be printing x? No, I want to be printing I. Okay. Turn it into, oh, I'm sorry, I. All right. So now we have a very simple code inside of the main. We have a very simple loop. It's going to go 10 times. And then we're going to use this control variable called I for the loop, and we're going to be printing the value of that. So am I worried about this 5s thing? Nope, I'm going to do that later at another step. This kind of approach where we step our way through the writing of the program. This is going to pay off really well for us. Don't try to do too much at the same time. Okay, so now we've done a pretty simple program. We're going to print I 10 times, and you would think, oh, that's probably going to print 10 lines 1 through 10. Well, let's look. Let's give it a run. Ooh, it finished with 9. And it started with 0. Oh, there's 10 of them. They just have the wrong value. The whole series is shifted by 1. Okay, and it turns out that in a lot of these things, the counting is going to start with 0. Why? There's a tradition. It's kind of a computer science way of thinking, all that kind of stuff. So how could we fix that? Well, instead of saying we want to print I, which is instead of the name of the variable, let's use a +1. So let's have this thing, it's called an expression here, I plus 1. Okay. And what's going to happen is instead of starting with 0, it should start with 1. And instead of ending with 9, it should end with 10. Okay, let's give that a run. See how that looks. Okay. What's that giving us? Well, it's giving us 1 through 10. Well, that's great. Well, that's pretty close that we want. We're just off by a factor of 5, aren't we? Okay. Now, what could we do? Well, we could do a lot of things, but what I'm going to do is I'm going to just do something. I'm going to change this expression. I'm going to make the formula more complex, and I'm going to take the value we have so far and multiply it by 5. So instead of starting with 1, we'll start at 5, and instead of ending with 10, we'll end with 50. So how do we express something like that? Pretty much like algebra. And we'll be learning the details of it. But I'm just going to take this expression we have already, I plus 1, and I'm going to put that into parentheses in the same sense we would do that in algebra. Okay. So that's a quantity. And then I'm going to say I want to multiply. That's an asterisk. And then I want to multiply by 5. That's a 5. So take that value we had calculated already, I plus 1, and each time multiply that value times 5. That easy. Okay, let's give this a test. There it is. 5, 10, 15, 20, blah, 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 blah. It's done. Okay. Now, how do we do it? Well, we started with something that was way too complex for what we needed. We just needed a simple loop, and we're going to learn about loops in the next couple chapters. But we borrowed the loop from it. We threw out the rest of the stuff, and we simplified what was in there. We decided that we were going to use the value of this control variable. We realized that we had an off by 1 problem, so we had to use I plus 1 instead of I. And then we realized that we were different from where we wanted to be by a factor of 5, so we changed this expression. We put this I plus 1 in parens, and we multiplied by 5. And we're all done. And of course, we are still using the situation where our working code is in main, and we just have one line out in the clear that calls it. And that's it. And let's run it again because it's fun. And again, and again. Well, I could do this all day. So that is it, okay? Welcome.py should give you enough information that you should be able to do the assignment solong.py, and math 505.py should give you enough information that you should be able to do math 101.py, and then you just have to remember how to save this and zip it up and submit it as your assignment. And we'll be talking about it in our next class. So that's all for now. I'll see you next time. Bye-bye.